Okay. So yeah, so far I was just talking about these hosts and various services. So I was talking about something called HDFS client. HDFS client is what does all the communication with name node and data node. An HDFS client can also be very, very useful when you are remotely copying the data, right? So you install Hadoop client, meaning command line. In while configuring command line in the etc Hadoop, and then there's a config file. In that you mention that your data node and name node is there somewhere remotely, at a remote location. And once you do that, whatever command you are executing over here using Hadoop, Hadoop, FS, and then LS, it will run on that remote server. Okay, and you can copy the file, you can see the file from your local one, right? As an example, I can actually configure my Mac to talk to my data center. All right. All only thing you have to do is you have to make sure that both of these machines are password free by setting up proper SSH. All right. So so that is something. Now all the services are up on Hadoop one. That's why it shows nice tick mark. And whenever you are installing your data center in your data center, based on okay, okay, right. So all I'm saying here that we have used Ambari for provisioning multiple server. If you do not have, say, Ambari or some Cloudera server manager, it becomes very difficult to install all of these all of these things on various machines. And in an organization, if you are responsible for setting up Hadoop, you might prefer something like a Puppet. A Puppet. So if you have, other than Hadoop and other than you have your own services also, using Puppet, you can install a software on hundreds of thousands of servers at a single shot. Okay. So Puppet is a pretty good software for provisioning of of your data center, right? So these are few tools you need to know, because all of these are open source and free. So you do not have to pay every time. So Hadoop fs-ls will give files from all the nodes. Yes, you do not have to worry about that. Okay. That was Pranav's question I was answering. So all the magic where it is connecting to name node, asking where is this file or what are the files available, is you know and then going to actual node and getting the files is done by Hadoop client. So your Hadoop client needs to know where is name node, where is the data node, right? And therefore, while configuring your Hadoop client, you need to tell them. So let me just demonstrate to you that in etc Hadoop, okay, you have conf, and under conf you have something called Hadoop site.xml. All right, Hadoop, not Hadoop site, HDFS site. Okay, HDFS site.xml. Now you can do an VI. In case you are not comfortable with VI command, you can use Pico or you can use Nano. You can use Nano probably. Nano is good. Okay, because Nano has less small learning curve. I have installed Nano on all the nodes. All right, Nano is a good editor. So you can open up the configuration file and then you can see that in this one we have mentioned that the DFS data node address is this. Okay, and similarly we have mentioned that Okay, we have mentioned that our name node, our DFS name node HTTP address is this. Okay, so the client will discover the name node at this location. Okay, make sense to you? So this is a configuration file for your Hadoop. So when you once you install Hadoop client, you'll have to edit your HDFS site to point to the various data node and name node. First, all you need to give is the local data node address plus a name node. Okay. So here, okay. So that's pretty much it. All right. And all right. So yeah, somebody has a question. So if we want to install any other service, we need to add configuration to Hadoop site. Yeah. So any other service you need to install, you can basically, yeah. If you see etc Hadoop, you'll see lot of configuration file under this. Okay. You'll see lot of configuration file. You have a yarn configuration file and you have mapred configuration file. So almost all the configuration files are located in this folder. Okay. So if you want to install any other service, we should add configuration to her. Not really. So in case you're installing some other service, say, let me just go to HBase. Okay. So for example, Hive. If you are installing Hive catalog or Hive service, so you have to, this folder is etc Hive, right? So every service comes up with their own folder, own configuration folder. So here under configuration, you will see there's something called Hive site, right? In this Hive site, we have to mention various configuration options for Hive, and also you know we have to configure this Hive by ourselves, right? And here Hive meta store, we have to tell that this is where you need to install. So all of the, I mean to say that every utility, every component which is under the umbrella of Hadoop might come with its own folder, except for the two, which is HDFS and MapReduce. They are generally, they keep their uh, configuration in the same folder. Here you can see there are four folders with one is Hadoop, Hive, HBase, Hive Catalog, Hive Web Chat, and these things. So basically, under Hadoop, you will find the configuration settings for your basic HDFS and MapReduce, while HBase has its own, Hive has its own, right, and Pig has its own folder. Okay, Pig has its own folder. So okay, so this is Pig's file, right? So if you want to install any other service, no, when you want to install any other service, you will have to install separately. Okay. But the general strategy is we do not install manually any of these services. If you install manually, you will not be able to even handle four servers. Okay. It will become a complete nuisance to manage even four machines. Therefore, either use Puppet or use Ambari or use Cloudera cluster manager. But I found Ambari the most intuitive and stable one, and therefore I after trying out Cloudera, I settled down for Ambari. Ambari is only for provisioning Hadoop services around Hadoop on your cluster. But if you are in a large enterprise where there is a big cluster and you need to keep on provisioning, you might prefer something like a Puppet. Okay. So that was something I wanted to quickly brief. Okay. And in case you guys want how to install and all, let me know. I can take a small session in which I'll have a I'll have a clean two node cluster, and will give you a demo on how to set up Ambari. All right. In case you want, just drop me an email, and then I'll take a session. So do you guys want to learn how to set up Hadoop cluster? Just say yes or no. Okay. Pranav wants it. Prasanna, Karthik. Okay, okay. Krish. Okay, okay. So then I'll make sure that I was under the impression that most of the people do not want to do not want to get into Hadoop installation. Okay, then I'll make sure that I'll include. I'll just make a note to myself. Okay, okay. Prepare the installation demo. Okay. So this I'm just making a note to myself. Right. Great, great. So because the way I have installed Ambari, I can give a demonstration, and you guys can continue setting it up. All right. But it requires a bit of patience and you know keep on checking everything, getting acquainted with the server, what is where is the log, in case where are the services on your machine. Those small details you might need to know a bit. All right. Now I wanted to demonstrate to you where I left off yesterday. Okay. So I was trying to execute something called training 2. Okay. Before I spoil the workspace, I'm just moving training 2 to my folder as Giri. And here we have training 2, this one. This has my classes of the mapper, reducer, the driver. Okay. So the driver's name was stub driver. So I say Hadoop. Hadoop is the main command. Then jar. Then my jar name. What is my jar name? Training2.jar. And then I say com dot no big data, the whole name, dot step driver. This is my class name. Now let's see what happens. It says you need to run step driver with the input directory and output directory. And let me see, where is my input directory? Input directory is under as Giri. This is on HDFS, right? So you have Hadoop ls as Giri, Hadoop fs minus ls, right? So yes, so there is this folder called sgiri/word count. Under that there is input directory, output directory. Okay, this output directory is already created from my previous run. So in case you do that, it will give an error. So let me just say input, and then try to just put this as output. So it will give you an error. Just make a note of that error in case. Uh, why I'm emphasizing on this folder is because there was similar question asked to some people, that what happens if you, right? So okay, good. So it's not there. Now we can just take these folder and right, go. So it says Hadoop jar, my jar containing all the things, and then my class name, the entry point, the driver, which stitches everything together, which basically creates a Hadoop job by specifying where is my input files located, and by reading the command line arguments, and telling that this is my class map class, this is my reduce class. Now as it starts, as this map reduce process starts, if you remember, we are basically trying to do a word count, simple standard word count. And so it says that this is the timeline service available. Okay. and connecting to resource manager at this, okay, Hadoop one, and these are the things, and the URL to track the service is here. Okay, let me just see what's going on at the URL. Okay, here it says map reduce, map 100% complete, reduce is running. Okay, so let's just see what is there going on there. So this one is, this is my job. Okay, and there is 10 reducers automatically created, and because in our, I think in our file we had mentioned that we want 10 reducers. Okay, therefore it has created 10 reduces. Okay, let me just see what we said. So it reduced everything. It says number of byte read this much, written this much, and all of these details are there. Okay, so total time spent in all maps is equal, I mean in occupied slots this. Okay, and okay, okay, right. So this much of the data transfer happened in the shuffling. Okay, and yeah. So let me just see. This was our code, right? And under this, this is our step driver, right? In this, yeah, we had specified, we have set number of reduced tasks as 10. Therefore, 10 parallel tasks were executed. And if you see the folder, what is the folder where we have stored everything? Quick, somebody, where did we store everything? In this folder, Hadoop fs minus ls. So under output 1, which was not there earlier, there are 10 files created. You see, part 1, part 2, because we have specified 10 reduced tasks. So each reduced task will be running on different nodes, or maybe on the same node, and all of them will be parallelly writing to HDFS, right? So in case you need to concatenate all the output, okay, or you want to just see one particular file, so what you can do is output slash. You can say cat means printing the output to the standard output, and let me just say, right, and say more. So it shows that the partly part of the data. If you say star over here, it will concatenate all of the data. See, right? So if you see how many lines are there, it might take a bit of time. So there are 81,000 lines in total. And how much lines are there in a single one? So each single one is having how much? These many lines, right? And good. So Ishwar is saying that how do we verify that output is correct or wrong? That's a very difficult question to answer actually. Okay. So the way we verify the output is you should have, you know, a smaller output handcrafted generated by you. Okay, so the way I would do is I will take, say for example, this line, right? I'll take this output line as is and print it into the file a million times. Okay, say for example, I just take these words, okay, um, or say sequence 1 to 10,000 do echo. Okay, I'm just trying to generate a lot of data, right? This is a huge data, right? Now, in this, for sure, that how many, so how many words will be there? 1 2, 3, 4, 5, 6 into how many? 6 into a million, right? So each of the word will come, uh, this 2 will come twice. Okay, say we have this line, right? Now or we have this line. Okay, so which means that this will come 1 million times, and all of these words will come 1 million times except for 2, which will come 2 million times. So it generates such kind of already predicted data, right? And then you store it in my data, right? This is, I'm just generating it very quickly. Let's see how long does it take, right? And so basically 1 billion strings of this form. I'm not sure how long it is going to take. I've just done it. How long is it going to take to generate such data? Basically printing this file 1 million times in this file. Okay, so it is done, right? It has got 1 million times. Now if you put this, if you copy this Hadoop fs minus copy from local, and let me just create a folder first. Okay, make a directory under this, and I call it sample, right? So I'm making a directory, and then I'm saying copy from local. Basically with this file which I've just created, I'm copying it to somewhere, okay, in the sample. Or in case your data is huge, a sensible thing to do is move that data, right? I'm removing this data. So in case your data is huge, that means it is going to be duplicated. And in case you don't have a space, so in those cases, instead of saying copy, you should just move the data from local to there. And that move command is specifically provided for that purpose. As and when it's copying the data to the remote, it keeps on deleting it so that you have the space locally, right? Specifically if you have many files, right? Now I have copied my file, my data onto that, you know, that folder. Now let me see if we run the same command which we ran earlier on this data, right? So we had run the same command like this one, right? Now I would like to run it on the same data. I'd created sample folder for just this one, and I'm going to say, what was this folder? Okay, I say sample and my data. All right, and this is my, let me see what does it say. Okay, so basically it is trying to read my file called my data, and then so ideally all of the strings, enable and everything, should have 1000, 1 million each. Let's see what happens, because here there are only how many words? One, two, three, four, 5 words, and we have said reduce equals 10. So there is a mismatch, because some of the reduce have to be empty. Let's see what happens in this case. So are you guys with me when what exactly am I trying to do, right? So I'm trying to answer Krishna's question in a manner with an example. Okay, are you guys with me? Great, great. So now let's just see what. So we said our this driver is little generic. Okay, it can take any input folder from the command line. The way we have written it is that we read from the command line and then said that this is my input folder and this is my output folder. So let's just see what is going on inside this. Okay, and say fs, and I say, so still there are 10 folders, and I want to see that what is inside each of these guys. Not this, not this, I don't want this. Let's sample as Giri sample output R1. Okay, so let me just see what is inside each. This is empty, so only, okay, yeah, I was right. So as you can see that for in sequence, so I'm actually exhaustively using my cell skills to quickly do something repetitive, you know, as simple as that, generating numbers from 1 to 10. Okay, 1 to 10. So let me, so in case you guys are not fan of cell script, you may not like it. So what I'm trying to do is I'll execute this command. Okay, Hadoop, Hadoop, fs, and I say echo. This is just for marking it, right? And here what I'm trying to do is I'll execute this command called cat, and get, right? So this command will be executed, Hadoop blah blah blah. Now let me just remove echo from the command and run the commands. Okay, so I'm trying to display the content of each files, each 10 files, and what do they have. So zeroth file do not have anything, first file doesn't have anything, second doesn't have anything, third one is unable came 1 million times, output came 1 million times. These are the word count, right? Stream came 1 million times, write came 1 million times, right? 2 has 2 million times, which means our MapReduce is doing a good job. Ishwar? So all I did was generated the data. I generated the data for myself, for our own sake, and then run it through. All right. So the important aspect is a very good question, and this is where probably most of the data scientists find it difficult to do the job, right? So whenever we talk about big data, the two aspect, first, data transport, how do we move data from one place to another, and the testing. These two aspects are heavily underrated, and most of us keep on ignoring these two aspects because both of these problems are really difficult. So most of the people, when they face when they face a challenge of big data transport or big data testing, they generally you know skip these two aspects, and they struggle a lot with both these aspects, right? So for example, let's say that you are doing a predictive analysis of say you are at Amazon, the section which gives you may also like these items. Okay, so you have to test that portion. How would you test that portion? It is a very difficult task to test the predictions of an algorithm, because predictions means that nobody knows about them yet, right? So in those cases you have to be creative and figure out whether on whether if given an older data, say you have got uh, how should I describe? So you have got people watching movies, right? And based on their history of ratings, you are trying to recommend them these movies. Now, the standard way is to split this input data into two sets, run your predictive analysis on the first half, and compare your results with the second half. Which means, had you given predictions in past, you could have been really right. So you are just verifying this part. Right? So So this is just a very quick way of testing whether your algorithm is correct, and I see that this thing is really good in testing it, right? So this was a hands-on, right? So Pranav question is why there are four reducers, right? Now let me just go back to my example again. So all we have is this single line. Where is the single line? Okay. If you just want to see first 10 last 10 lines of a file, what do you do? Anybody? In case you just want to see the last 10 lines of a file, which command do you use? Anybody? Good, good. So we say fs tail, and then or maybe head tail as giri, and then we had sample, not this, sample, and then my data, right? So there are effectively only five words, right? Five words. This each of this word we converted into, say, let's say this one, right? Let's say this one. Okay. So we took this, right, and replaced space with space with new line. Okay. This is what we did. We said replace space with new line, right? And now uh, and other than that, what we did was, okay, how can I do this really well? So I said this, and after each word we have also put, in case you guys are not aware of regex, make sure that you learn it. Okay. So we have also put one after all of this, right? As part of our mapper, all our mapper did was converted our file, like whatever file we had, into this format, right? And so if you see, there are only five words, and these all five words, each of them has to be go through the reducer. So I've just sorted it. So enable, and all the values of enable, how many values are for enable? Two values, right? So these two values, both of these are should go to the single reducer, right? That's the whole promise of the reducer. For a key, all the values will be passed through your reducer code, right? If if the same key is say if the same key, it's like grouping. When you group a value, all the values with respect to that grouped column have to come together, and therefore there will be only how many words? um, so this will go like that. Similarly, so effectively you have only these groups left, right? Only five. So uh, so they have to be run only through a single reducer now. So this one, enable, will have to run on single reducer. Okay, right. If we had 10 unique words, then all reducers would have value and count. Perfect. Yes, the chances are that all of them node will get one keyword. That's the chance, right? So you got the point, right? So now it cannot say that enable So for one, it sends, say for example, these two, on one node this write goes and on another this write goes. That whole objective of reduce or grouping will fail badly, right? This is as per the design, right? So effectively there were five, not four reducers. Okay, effectively there were five reducers. You can see that here, right? One, two, three, four, and okay, yeah, there could be four also here, right? Yeah. So there's nothing wrong in it. If you see why is it so, is because here on the second node, in the second node, both these key went, right? Both the keys went. So first, if your question is that why few nodes are empty, I have answered that one, because it's not possible to spread these keys on multiple nodes. Now the question is why only four, not five? Because Hadoop did not do an analysis before starting the job, right? Before starting the job, it did not count that how many keywords would be equally divided. It took the input, it sliced them such that same keys are on the same node, but did not count that how can it uniformly divide the input data onto multiple nodes, because counting that itself will require a reducer, right? How many unique keys are there? To do that, it needs to group them and sort them, right? And therefore that's another step. So so to facilitate this uniformity of data or equal load sharing amongst reducers, if equal load sharing amongst reducers, Hadoop keeps on noting down your input data's behavior, and if we keep on running it again and again, it will note that what kind of behavior your data had, so that next time it will start distributing it uniformly, right? So so as Karthik was saying, that if we had 10 unique words, then all reducers will have a value and count. We'll be lucky if that happens. If maybe there are two keys go to a single server, but but one key will not go to two different servers, right? You got my point, right? So because it has to do an analysis upfront, and that analysis is exactly what reducer and all of this sorting and division phase does, right? So upfront it cannot predict that how can it uniformly divide the data among reducers. It just takes the keys and tries to divide it amongst nodes. Okay. So think about it. How would you divide the data before sorting it? Okay. So you got my point, right? So there is no partitioning coming in here. Okay. There is no partitioning coming in here. We can do the partitioning. It's a good point to raise, that we can define a combiner class over here, right? And as I said, partitioning is a choice. It's not mandatory to have a partitioner. Okay. So if we had a partitioner, if which said that if key equals unable, right? And return 0, and if output is if output is if key is output if key is output if key is output and return 1, and so on, right? Then we could have distributed these keys equally onto other nodes, right? So this is the partitioner's role, but is partitioner is optional thing, because I mean, by default it tries to do the partitioning at its own, which may not be uniform two keys might, or maybe all three keys might end up at one node. Okay, if the data is very badly skewed. So hope I'm able to answer your questions. I'll just wait for a minute and then move on. So Krishna, the things are clear with respect to the partitioning and why did we have this? Right. So partitioning will basically, this logic of partitioning will will improve the distribution, will improve the distribution and thus performance overall. Yes, you're right. Right. So everybody on the same page? Is everybody on the same page, and should I move on? I'm getting only from Karthik, Pranav. Okay, great. Prasanna, there's a good part of having a small class. This is the smallest class I had. I mean, generally I have like 15 people, 16 people in the class, and it's difficult to remember everyone's name. This is good. This is good. Prasanna and Jagannath, should I move? Great. Now we have, sorry. Just started doing again, cancel. Good, good. So we did a good thing by demonstrating things quickly, and now it is very important exercise to actually go through things quickly, and maybe some of you can take up this project who is okay with the combiner class. Here if you can see, there is a combiner already here, right? There's already a combiner. So I have just put the same reducer as combiner, and that's interesting part. All right. So on the same node itself, the count will happen and the performance is improved. So instead of, so enable each node itself counting itself in case of, if your, if this file was on multiple nodes, right now this file is on the single node, right? If it was on the multiple node, it made sense to run the counts on the same node. And here the reducer code itself is what I have put as the combiner, right? Ideally this should not be the case. Ideally it should be this way, right? So in this case what I did was, because in this particular circumstance the data exchange after combining on a single node will be how many words? At most 5 words, right? At most 5 words. Therefore this, if this whole thing was running on a cluster and you were doing combiner, this will dramatically improve the performance, because because before the transfer of the data or the shuffling is happening, the data is being summarized by your combiner on that node itself, right? So all of you understand the value of a partitioner now and a combiner now. So there's a mapper, there's a reducer, there's a partitioner, and a combiner. Mapper converts your your input data into key value pairs. Okay, and the way the input data is prepared by input splits and records. So that's the whole dynamics about MapReduce. All right. Now I'm moving on. I'm moving on. Closing Eclipse. All right. So do not worry about the time and all. I have, even if we are going a little more, it is okay. Right. So, so do you guys have any other questions related to MapReduce? Because we are not going to touch MapReduce anymore, other than occasional questions, because most of other tools internally use MapReduce. Right. So any other questions with respect to MapReduce in any way? Just say no in case you don't have a question. Okay. Yeah. So Karthik's question is very valid. So there's a difference between version of Hadoop or MapReduce API. Yes. Right. Earlier there was no generics involved. Okay. There was no generics involved. Now there is a generics into place. So there are minor changes which have happened. The basic change, the major change happened in MapReduce 2.0. Though the older one also runs well, the older ones will also run well. You just need to recompile it once. Okay. Because older classes are also still there. So while writing your map code, you generally extend a class or implement an interface. Those new ones have come in and old ones are also there. So for the backward compatibility. So but they so although for backward compatibility after some time those things will be removed, right? But and because there has been a change in the API over a period of time, right? So I mean, as Java started supporting other like the generics and other things, they kept on including those ones. And maybe in the future versions of Hadoop, there will be a new change with respect to lambda functions. There's a lambda functions introduced in Java 7, right? So Apache Spark is already using lambda functions for its work in the Java version of Apache Spark. So similarly, Hadoop, usual MapReduce will also start using the lambda functions, right? Yeah, I think it's in Java 8. You're right, Ishwar. Yeah, right. So there is going to be a little bit of difference, and this might go annoying at a various period of time. Therefore, in case you are writing in Java, it's good to have the API docs open. Those people who are using the streaming jobs, they don't have to worry about the compatibility. Streaming jobs has been stably compatible since the day zero till today. Okay, the specifications are fairly standard. The only thing that changes with respect to the streaming jobs is they keep on introducing more variables to the command line. That's it. Nothing other than that, right? So now today we are going to discuss something called pig. Pig is an engine for executing data flows in parallel on Hadoop. Okay. So, so we did face some problems while writing our MapReduce jobs, right? First one was the code was repetitive. Second one was there were some limitations. I'll come back to them again. So a pig is basically an engine for executing data flows in parallel. When you do have to do a lot of data processing, and that too on a big data. Big data means that a huge data you can't handle at a single machine. If we could handle on the single machine, we'll just use the Unix command line and process the whole data, or we will use the SQL to process the whole data. Now, now we have got Pig has got a language which is called Pig Latin. It provides similar to SQL. It provides these operators like join, order by, filter, group by, and so on, which is very similar to SQL, but far more easier and far more it it makes user very comfortable to use. Okay. And the data flows from top down, and it runs on Hadoop. It makes use of both HDFS and MapReduce to make it really really fast. As a blatant example, I mean blatant. Why I'm saying blatant? Because you don't know anything about Pig yet, and still I'm giving this example. So this one is like you take a big text file. So this is the syntax of Pig, right? This is the syntax of Pig, where first line is load the input line, input from big.txt, and you define a variable called line. Okay, right? You're saying that you're in the after you have loaded the big text into input, it'll be like a it'll be in a variable called line. We'll talk about these things in detail more. Now, what you do is you whatever line you have read here, okay, you iterate over line by line, tokenize the line, meaning split the line by space, and then flatten it, which means this is the job of the mapper which we did. Word w1 1, w2 2, w2 1, and so on, right? So first word and followed by one, second word then followed by one, and so on. And that will be the output here. Now after that you group it, and then after grouping you iterate again the way for each here, the iterate again over the grouped ones, and then you count them, and then you print the output, right? So that's a big word count example to do. Okay, you can try out this one very quickly. Pig does not have a server. Pig only has a client. Okay, so Pig, you talk to Pig client in Pig Latin and tell that this is what you are trying to do, and Pig client will convert your query underneath and call the MapReduce. Okay, and it does it for you magically. Okay, so Pig Latin is basically a data flow language. It allows you to describe how is your data is going to flow. The way we said here, the data flows from big.txt into input, and from input the data for input we read the line by line and then tokenized it. Then the data went into words, and then we grouped the words, and data got into grouped, and from grouped we iterated over grouped, and then we got here, and after that we said dump this, and then we got the output. Okay, right? So it allows you to describe how the data should be read, processed, and stored on multiple outputs in parallel, right? And it lets you prepare the complex workflows. If you remember, if we have to do multiple things in SQL, either we create temporary files, or or we create these complex joins, and that becomes extremely uncomfortable, right? the queries becomes really complex, and therefore it becomes very very unmanageable. I mean, having a big SQL query is a disaster most of the time. So, but in case of pigletin, it is quite comfortable. Here all of this is happening and there is no temporary file created. Okay, right? So we have got the data is split. So I will go into the details. Right now there is no, I mean, the other thing you should note is that other than for each, there are no other loops. There are no ifs or else's, which means that the general way of doing programming is not what Pig Latin is. It is more like SQL, where if conditions are not part of the main logic. So this is a slight difference between Pig Latin and SQL. User describe exactly how to process the input data. That's what happens in Pig Latin. SQL lets you describe what question they want answered, right? So in SQL, you are more concerned about your output. You leave most of the job to SQL, saying SQL will do its job really good. But in Pig Latin, you write your SQL and then you also help. Sorry, you write your Pig Latin. You also help Pig to optimize your workflow. It provides you syntax like parallel, and you can force the way we have set number of reducers just now to 10. In the similar manner, you can force it to run it parallelly on how many machines. So similar syntaxes it provides you. And Big Latin is basically designed for big data, while SQL is designed for RDBMS. And Big Latin targets multiple data operations and parallel processing, while SQL is uh, also for the, I mean, it's for generally the in a single shot you get an answer. Okay, in a single shot you get an answer. In Pig Latin, your data, the way we have just showed you, that big.txt was a plain text file, and we quickly passed it and formed our input data. So in case of Pig Latin, the input may not be well formed. It may be partially formed, and it can handle that as well. While in case of SQL, you need to have the clean data to be available in the tables, where there is a we can clearly say that this is the column and these are the values. So that's a big difference between Pig and Latin. Now, why do we need Pig Latin when we had MapReduce in place? First, Pig Latin provides you join, filter, group by, and order by, and union. These are very, very powerful operators. These are very powerful operators when we use it. If you try to do the same thing in MapReduce, even the high-end programmer has to think twice and will make a mistake. The five problems which we discussed in the first session, specifically the last one where we had to do the join. To do the join in MapReduce requires a lot of code, a repetitive code, or require and it has a larger chance of error. Fourth problem with respect to MapReduce is that the code need to be compiled and then moved. Right? It's a long cycle of development and it becomes very irritating that first you need to develop it. You need to have this. I mean, when you're writing code in Java, you require an IDE as complex as Eclipse, and then you generate your jar, upload it there, then run it. It becomes very, very irritating. If I have to do things personally, I would prefer the streaming job over my Java code. Okay, if it is not too big a job, too big a task, and so my first preference is generally to use Pig. Then if the Pig is not sufficing, I go for UDF. user defined functions in pig. And then if that too does not suffices, then I move to MapReduce, but in Python streaming. And if that is not sufficing, then I move ahead with MapReduce in Java. So, but you would not need MapReduce in Java per se again. Okay, most of the job you can actually finish in the piglet in itself. Okay. So that's pretty much about comparison between pigletin and MapReduce and pigletin and SQL. As you study more about pigletin, so how about advanced MapReduce? Right. So most of the task, the way we had described in the advanced MapReduce, like uh, how do you read the data input, all of that can be very well done using user defined functions in case of pigletin. Similarly, number of parallel tasks you want to run, in case you want to do the statistics analysis, the way you asked a question, that why there are only four reduced tasks, why they not five, why were our five keywords not uniformly distributed onto onto all the five nodes. Okay, right? So while I mean in our case we just run, like there were six nodes which were empty, four were busy. There were chances that we could actually spread it over to five nodes, but it could not do that. Those kind of logic, like partitioner, can be defined for piglatin. Okay, so all the tasks, most of the tasks as part of advanced MapReduce can be very well done using piglatin itself. Okay, and exactly for advanced MapReduce, AMD's optimization, we had to people had to invent piglatin, or people had to invent pig, because those things were needed, optimization was needed, because these minor optimization leads to 10x times 10x times improvement, or 100 times improvement, or 1000 times improvements, but were not possible using standard SQL syntax. Okay. So therefore that's the primary reason why they have to invent piglet in first place, right? So effectively, your question about advanced MapReduce is the reason why the pigletin was actually invented, as opposed to the Hive, which is SQL client, right? Now, there are various use cases of pigletin, and as you will move ahead, this will become your primary way of churning the data. Okay, whether the data is in in CSV format, tab separated format, or any other format, you will read it using pig, generate your analysis, save it in a table, or in a you will save it in the file, and once you are done with the saving it in a file, you can read that file using your standard BI tool, and then represent the data. All right, it's as simple as that. Right, so we have got ETL, extract, transform, and load kind of job, to which are very good use case of pig. Second is research on the data, like if you want to do all sorts of magic, right? You can use piglet into a very large extent. Then iterative batch processing. Okay, if, I mean if you have a job which runs every day at a particular time, you can use piglatin for that kind of job also. Okay, so at one extreme lies the MapReduce, and the other extreme lies the SQL. MapReduce requires a lot of coding, requires a lot of time, but is very powerful in the sense that you can do a lot of things, lot of powerful things, functions which are not there in the in pig, or any other things. You can do those things using, say if you have to do the problem which we discussed, like anagram, where we sorted the array by characters. Doing that thing in pig is a very difficult task. Okay, So MapReduce provides you flexibility, but is time consuming and requires a lot of skill. While SQL is extremely simple and people know about SQL very well, SQL is not very was not even the syntax was not flexible to make it really fast. Such as, how do we specify that we need 10 reducers, or how do we specify that we need to do a lot of things in parallel. So those kinds of syntax were not possible in SQL, and therefore you are with pig you are sort of in between, halfway, because you also control how your data is going to be read and executed, while in SQL you don't bother about that part, because that is done neatly by SQL. At most what you do is you keep on creating these indexes on various tables to make it optimized, right? So the philosophy with respect to pig is this. The first syntax for first point is that these are the four pillars of the pig's philosophy, with which most of the system is designed with respect to these four pillars. Okay, A is pig eats anything, which means P is not so peculiar about the data, right? The way in SQL our data has to be in the database before we can run any SQL against it. Okay, and in when we have to import the data into SQL, the data has to have a data type. Okay, if you have put your integer if you have put your integer as string in the in the database table, it will become very difficult to handle that in the sense that every time you have to write a I mean indexes will not work properly, and there are multiple kinds of problems. But in case of pig is designed such that whether your data is structured, semi-structured, or unstructured, pig should be able to handle it. Or you have already defined data types. Partially data, you can define partial data type for some columns. For some columns, you don't have to define the data types. Okay. So that's the first pillar. Pig eats anything. Then pig lives anywhere. The overall objective of pig is not only Hadoop, but any kind of parallel systems that come into play. For example, the newer system like Apache Spark, which is coming into, now we have, you know, pig's version on Spark. Okay. So basically, the objective is to wherever there is a parallel processing, data's parallel processing, pig has to be developed there. Pig's client should be there. That is another one. Pig are domestic animals, which means pigs are controllable. They don't run at their own whims and fancies. I mean, any piggy script you should be able to control each and every aspect, right? Meaning, in case there is something which is not there in pig, you should be able to define it via your Java function or Python function, or you should be able to define your custom load methods. If your input is containing a particular format which is not there in the standard library, you should be able to define it, right? Then pigs fly. The fourth pillar and the most important aspect of pig is that anything anything pig do should be really fast, or it should give a control to the user so that user can optimize it, right? How many threads need to be run, how the data parallelly need to be processed, and all of that. Okay, right? So to install, in case you don't have pig on a machine, ideally you should be using Ambari for installing any of this. Like we have Ambari over here. uh, okay, so we have dashboard and we have this pig client, right? I have installed pig client on all four machines, right? So nothing on this part. Actions, what you can do is on selected host, filtered host. I'm just wondering, how do you, yeah, service action, run service check. Let me just do a service check. So all I did was I selected pig and did this. Similarly, we have Tez client, Scoop client, and all those clients. Okay. So only one of the recent servers is live, which means two are dead. Okay. And how can we actions, selected hosts, recent servers, start. Right. So ideally you should be using Ambari to use to for the uh, for pig installation of pig. But in case you want to install pig on on a node which is not a part of cluster, then you can, or a part of cluster also, this is how it is done. Download from the pig, download the latest version from pig, and then extract it somewhere, move it to user local pig, and then you define a home, Java home, like this. And then and the next step is that here, once you have done this part, which means you have installed pig locally, even if there is no Hadoop uh, available, pig should be able to run by using pig minus x local. I'll show you that part. Okay. So here, let me show you. So pig minus x local is running in the local mode. We have got grunt. Grunt is the command prompt for the pig. Okay. Similarly, once you have downloaded it, unzipped it, and then moved it locally, and then set the Java home folder, because pig under the hood is written in Java, and but though you don't have to do anything with that, but only you have to set the where is Java located. That's all. Okay. And once it is started working, which means it has been installed perfectly locally, all you need to do is you need to specify where is your Hadoop located, where is the config file or config folder of Hadoop. Okay. As I showed you, the config folder of our Hadoop was located at etc Hadoop. Okay. Okay. So generally this is not the place here. This is where the config folder of the Hadoop is located. So you just generally mention it like this. Okay. In our servers, you don't have to do this. I'm just giving you for the sake of example. Now, once you have specified, you have told your pig client, which is command line client, okay, which is local, that hey, this is where my Hadoop config is. Go and find out by yourself where is Hadoop name node, data node, or whatever. Okay. So that's what you told to pig, right? By X. And then you then if you run this, it should connect to the Hadoop. Otherwise it will give an error. So it figured out that this is where the HDFS is, right? Now this is where you write your code. Okay. A equals load blah blah blah. Also, if you're running in pig minus x local mode, any file you refer will be local file. If you're running in this mode after setting up the pig class path in the remote mode, where anything you do will be executed remotely, to do that, uh, I mean, if you're running in the remote mode and you load a file or do something, the file should be in HDFS. We'll see that in a minute. All right. So yeah. So I'm taking a break for 10 minutes now, right? Let's take a break of 10 minutes. In the meantime, you should give it a try. Give a try. You can SSH onto any nodes, right? You can SSH, say, here I'm trying to say SSH student at Hadoop 4 dot no big data, no big data.com, right? So here also, if pig is there, right? So any of the node from 1, 2, 3, 4, you can use pig and it goes cool. And most of the SQL, your query processing will be happening in there, right? And yeah, that's pretty much. Okay. So we will discuss this. I'll just leave it here. And so you can do any of it, any of, you know, Hadoop 1, 1, 2, 3, 4, any of this. Okay. You can also try Hadoop 2, 3, 4, right? So that's break time now, and let's come back at 10:30, 10:13. Okay. And also, as we discuss, you should keep on trying out these commands. Okay. Hi guys, I'm back. Hi guys, I'm back. Can you hear me? Great, great, great. So, pig, as in, you know, as a quick survey from my other student. So even when people were very very comfortable with SQL and comfortable with Java and other language, when I asked them to do some project, the first thing they picked was pig. Okay, they did not pick SQL or Hive. They picked pig, and they found it more comforting, and they were able to do it. So mm, what I'm trying to say is that, and that is probably the reason why pig has become so popular, because it's easy to learn and it is easy to operate upon. So so pay a little more attention, or at least keep these slides available to you when or you go through these slides after this session again, so that you get a more context of uh, about pig. All right, so we're going to talk about something called pig minus x local. It's a local mode and is very very handy, because whatever you do, say a simple job where you are loading 100 lines from a local CSV file and then running that one through your whole pig script, and just for testing purpose. So pig minus x local is a very very handy tool. Say pig minus x local. It's a very handy tool. So anything you do is will be you'll be handling from the local file system. You don't require Hadoop for this. Okay. So generally the way you will be doing your work is have pig client installed locally and run a local mode onto your machine, and then when you have to when your pig script is ready, you can run on the cluster. There's a general thumb rule we follow in organizations where your data is hues, actual data hues. So you take a small sample from the hues data. They say t- uh, tail, using tail, you took a small file and then kept on running your pig on top of it. So that once you're very confident about your pig script, then you run it on the cluster. Okay, so that's where the pig local mode is used. It's right. So I mean, it's useless to say that it will improve your development performance, because you'll be doing it locally, and the speed of pig minus x is pretty fast, because it doesn't have to, for a small data, it doesn't have to, go to other nodes. Other than testing or other than development, there is no other use of pig minus x local. All right. Because if your data is small and you are able to handle it with pig minus x local, then you should be able to use your standard tools, whatever you are using. So this is not a pig minus x local is not a big data solution for you, right? Now, before jumping into pig, the pig Latin, let me just describe you the command line called pig. So you say pig and then enter. So pig starts. You can also run your pig script by saying pig your script name. Okay. Your script doesn't have to a specific extension in case of any of the Unix program. You can just say whatever your script name is. So pig your script name, and then that's good. Now if you have just a single command and you want to just run a single command from time to time, you can use pig minus e and then this. Okay, it's a good way to say you want to see if there are thousands of directories and you want to go into you want to write a shell script and keep on calling pig. Okay, you can keep on calling pig with a single command. So all of these modes are really useful. Pig your script, pig minus e, or pig without any arguments. Okay, and you can see more options of pig by saying pig minus h. So it shows you a version of pig which we are using, and it runs a, there's an interactive cell, and then there is various commands you can execute, and then you can load a file. It's completely optional. Okay, the prompt is called grunt. I mean, that's how pig speaks. This is where all the commands are typed. You can also control Hadoop from here. Now I'll just show you. So I'll say pig. Now pig, because I have not said minus x local, it will be running all the commands on the, so I can say ls, and these are the directories, right? These are the files in my hdfs. So if I say ls asgiri, it should show us the folders under asgiri. And if you say sample, it should get my data and output, right? And under output you have this. So perfect. So we are able to execute all these commands. The other thing is we can say kill minus job, and the job id you can see from the when you run a map reduce job, there is a job id which is given. We can kill a particular job from here. Also from the command line itself. What is happening? Did somebody got disconnected or something? Yeah. So the other part is that, right? So yeah, and here it shows you those who are wondering that what is this? Can somebody quickly tell what is this? Anyone? This is okay. This is the file name. What exactly is this? Anybody? No. Anyone? Anyone? Quickly, quickly. What is this R and 1? It's basically the replica factor. Okay. It basically the replica factor associated with HDFS. And here I have set replication as 1, which means there is only one copy of this file. In case this particular data node goes boink, then my data is lost. It's not a good thing to do. I'll just set it temporarily replica factor as 1 because there are a lot of data transport is happening back and forth. So the disk space was not getting sufficient. So we have just set the replication factor as 1 for all the files. Okay. So okay. So you can run all these commands like fs, kill job. Also, you can do exec to execute a pig script from here itself, or you can run. There's a little bit of difference between exec and run. When you execute a script, then any changes that happen in that script, like variables are created or updated, those affect your general pig grunt also. While if you run a script, those variables do not impact you here. Okay. Now this is where I have uploaded the data. Let me just see. Do I have a data? And as you can see that it's very comfortable to use pig for talking to SDFS also. You don't have to keep on typing Hadoop every time. Okay. So ls and I say data. Now I have got this data. So let me just see what kind of data it is. This is my first script actually. Okay, cat this. Okay, okay, don't worry. Okay, so this is my data. Ideally, you should do a tail rather than cat, because if the data is huge, how come the tail is not there? It says, so you have cat clear fs as such, copy this. Okay, let me see what does fs say. Okay, so in case the tail is tail, you can use this way, fs minus tail, right? Now we have got, this is what we have. All right, now what we want to do is, we have, first column is your New York Stock Exchange, then the symbol, then the date, and then the value of that stock, right? Value of that particular symbol. So stock symbol is CPO, and so on. What we want is, we want to do an average over here. We want to find out the average value of each one. How do we do that? Okay, this is the first assignment. So how do we do that? Let's just do it this way. So first we load the file. Okay, we load the file, and in case you don't understand it, don't panic. All right, so as you can see that there is a name of stock exchange, there is a ticker, or you can say symbol, then there is a date, and then there is a value, right? So I say this. Okay, it is loaded now. Now the next step is here. Let me just update this also. What is this? Okay, now you can say dump div, or you can say describe divs. Divs is your variable which you just defined. Okay, now what does this line means? Load this file and define these four columns out of this file. The default separator it will assume to be tab. Okay, now as you can see that when we say describe divs, those who are from SQL background know that describe means what is the data type of something. So divs, okay, divs is your variable of this type. It has got a name which is of type this, another one, and so on, right? Now to see what it actually is inside divs, what you can do is say dump divs. Okay, now it will, under the hood it will run whatever MapReduce are required, and it will dump the data for you. Okay, okay, fast. All right, let it run, let it run. Let it run. Okay, the second step is, other thing I forgot to explain is the explain command. Explain command gives you more detail about what is going to go. Now it has dump means we have just done a select star from my data. That's all, right? Now the second step is explain, also will do the similar thing. Explain. Also you noted that when we did this, it just finished in a flash, right? But when we did dump, it took a lot of time, which means the actual process started only when we did a dump. Before that, the whole process did not start. It's like the circuit is ready, but you haven't, and you have also connected one end of the battery, other end the end of the battery is not yet connected. The whole process does not happen. The moment you say dump, the whole process starts happening. Okay, now we say group. Okay, group, group divs, this is a syntax. So group the rows which you have just formed, the variable which is representing your data, group that data by a column called ticker, right? We have defined ticker as the second symbol, right? And we say this. Now you can see describe grouped. Now it'll show you what is there inside it. It says that this data has got group and it has got divs as the actual value. Okay, so this is the data it contains. Now you can go through this data and generate average. So iterate over grouped and generate group, whatever group was on ticker, right? So you will get a ticker and the average value of divs dot value, right? And then you can do a here. So now the sixth step is that whatever data is there in average. So what is there in the average? Let's just see. Dump average. Now the actual process will start. The whole process of computation will start. The moment you say dump or the moment you say store. All right. So the next step is whatever has come into average, it should be stored into a file, and then we'll see what's there in the file. All right. Come fast, come fast. So okay. So Pranav is saying that why divs dot value, not grouped dot value. Okay. Right. So we define divs, right? Divs is what it has. Okay. Grouped has further two portions, grouped dot group and grouped dot divs dot value, right? So this is what we had. If you see the describe, so this is what is computed. Now we can store this data, but when we store it, again the whole process will start again. Not this way. It should be what? It says error number 600 users. Okay, this folder, this file already exists. Okay, I'll just say this also exists, and then to okay, right. So we'll come back to that one again. Basically, we defined val as part of our variable called divs. Okay, and divs when grouped basically is still the same data type is followed. Okay, so now it's written happily, and now let's just say now we can say fs minus tail, and we should get average of each ticker. Okay, what is going on? Okay, store averaged into this, which means it should be there. And if I say fs minus tail, oh, what exactly is the wrong with it? Okay, basically we can say ls, and then it will tell you what ls. Yeah, so ls part. Right. So you've got this file which has average in it. All right. So this was a quick overview. Now we'll go into one by one. So first is that pig has got data types, right, which are similar to what data type you have in Java. So you've got int, which is integer, long, float, double, char array, and byte array. Char array is for storing strings, while byte array is uh, to store the bytes, the binary data. Now, pig has got complex data types such as map, tuple, and bag. So these basic data types are everybody is okay with them, right? Or do you have any questions with them? So as we showed you here, we define these variables. We can also define their data types. Okay, and it automatically guessed the data type of val, and we did not have to say that val is of type int, right, or double. Okay, now now the pig has got complex data types, right? Like with any of the programming languages. So a map is basically a key and a value pair, a collection of key and value pairs. Okay, the value can be a simple data type or a value can be another complex data type. Simple data type as in the basic primitive data type. This is scalar data type, you can say, while the value can be a scalar or it can be another complex. Okay, so that is map. Tuple is tuple is a fixed length ordered collection. Okay, meaning tuple is like a row of a table. It has got field and their data types and their order is fixed. Okay, so you can think of a tuple just like a row. If you guys are aware of tuple algebra, that's a row is referred to as a tuple. So you can either have a name for a column, or you can refer them by their position. So they are ordered. So example of a tuple is something like this: Bob 5512.3. Okay. While a bag is basically a collection of tuples. You can think of a bag as, set of rows. When you say select star from a table, you get a bag containing tuples. All right. So that's a bag. Bag is generally unordered collection. Okay. Right. So this is an example. It shows you that there are two tuples, this and this, in the curly brackets. Okay. And the representation is exactly this way. So in case of a map, the map is surrounded with a square bracket, and key and value are separated by a hash. And in case of a tuple, it's surrounded with round brackets and comma separated, while a bag is in the curly brackets and values are separated by comma, right? And this is the way it is. Okay, so two tuples with three field each is this bag contains. Okay, now this is analogous to set, or it's analogous to set of rows. Okay, if a bag is not fitting into the memory, it is saved partly on the disk. It's spilled over to the disk. Okay. Any questions related to the complex data type? Feel free to ask. It is, I mean, I'm expecting a lot of questions at this point. So you don't have any questions? So basically, when I mean, this thing will come very, very handy, and you will find it very useful, right? Okay. So the data types in Pig are scalar and complex. In complex, we have map. Map is like your hash table, key and value. While and then you have tuple. Tuple is a row. Basically, tuple is like a row. It may or may not have it will have a predefined fixed set of column names. And a bag has column names is referred as fields over here. And a bag is basically a collection of tuples. All right, schemas. So pig is not very particular, as we showed you that here when we were loading the data, here when we were loading the data, we never told pig that the value is a decimal. And when we did average over this, it did not complain. It did not complain to us that this data was this much. So it's more like an Excel sheet. Like in Excel sheet, you don't have to keep on defining schema, but you can define the schema, define the data type if you wish so. Okay, just to guide Excel sheet correctly, right? So that's exactly the data type behavior with respect to data type. Or the pig's behavior with respect to the data type is like that of an Excel sheet, which does not generally complain unless otherwise required. Okay. So either you can tell upfront that hey, these are the columns and these are the data types, or or you can simply let it be the way it is. Hello, hello, can you hear me? It kept on giving me some error with respect to sound. Okay, okay. Right. So you can either define upfront that your data type is this, like the way we have done. Exchange is char array, symbol is my char array, date is my char array, and dividend is a float. Or you can leave it and let it guess it based on the data, right? And the schema also, in case your data is in the form of complex form, you can define that while loading. Like my A is of map, right? In case your data is stored in this format, then you can load it in that way. Okay. Similarly, you can say that my data is in tuple, so load it. A is a tuple, or you can say A is a tuple where the first value is integer, second value is a byte array, and so on. Or my column is a bag of values, or the way you can do is you can say my column is a bag of bag containing the tuple. T is your, you have to write T colon. T is your syntax. So you say my column is a bag of tuples which, and the tuple inside the tuple is like this, the way you have defined above. My first one is the int, second one is the in, another int, and so on. You can define it that way. So you can quickly save your data as is, and then you can load it again using this syntax. Okay, I'll take an example of the complex data also, so that you are very clear about what I'm talking. Also, similar to Java, we can cast one variable into another, right? How to load the unstructured data? So you can load the unstructured data, and later on you can define that these are my columns. Okay. So, okay, let me understand. What do you mean by unstructured first of all? Because unstructured seems to have multiple definition, and everybody has their own. Right. So the way we have done here, let me just go back to the first example, right? Where did we do something about this? Here, right? So here a line was this big.txt is unstructured data. It's a plain free flowing text, right? And we loaded that and tokenized it. So you can load that kind of data easily into the into Pig, and Pig won't complain. And then you can form the schema and do the operations, right? Perfect, perfect. Also, as you saw in the example, every operation, every step was resulting in a new set. We did a group by, we got grouped, and every step was resulting in the new set. Okay. Pig is basically a case insensitive. Okay. And the commands are similar to Java and combined with their single line comments from SQL dash dash, right? Now, okay. So now I will break down the whole thing into step by step, right? So let's talk about something. The first step in the whole game is loading the data, right? So the way we did was this, okay? We can do cd data and then, yeah. So, right? And let's say I say dump divs. Will it dump? Good. So basically you can do cd and then you don't have to keep on specifying the absolute path. Right? So cd data, I have put all of this data for today's exercise into a folder called data in the home folder of the student. Okay. So not this one. Let's just go to hue. Okay. Let's just go to hue. Let's just go to hue. So under hue you have file browser. You have this nice file browser. Under this there is a folder called data. In this data I have already dumped all of this today's work. Okay. You have got NYSE daily. This is my the daily New York Stock Exchange values for sample. And you have got dividends, right? New York Stock Exchange dividend and so on. So I've just loaded it because it's in data folder. So you can load your data just like this. You have not defined any column at all. And when you say and it automatically figured out that there are these four columns because the data is by default tab separated. In case, okay, okay. So you can also give a absolute file location or the relative one, either will do. In case your data is comma separated, you can define, say, using pig storage, and then you can say comma. Also, you have multiple kind of loaders available which you can use for loading the data. All right. Now, if you have a regex separator based, you can use a regex separator based a pig storage also. All right. So this is what it is. So if your data is comma separated, you can use this way. Okay. Now dividend, let me have a look at dividend. Dividend is mostly it's a tab separated. And what about daily? Daily is also in this one. Now what about what about tweets? Okay, tweets is something which we can load and it's a comma separated. All right, it's a comma separated. Now, you can also do something like this. If you have hundreds of files, it will load all of those files into divs. Okay. Similarly, you can use the data from HBase using HBase storage. So, so your pig is not only for the files, HDFS files, you can also load the data from the database. And these loaders, there are a lot of loaders available from pig, which are there, something called, it's called, what do you call it? Pig, uh, what do you call it? I forgot. So pig, there's a library of pig in which you can download those functions and start using those. Okay, and also you can define the column names and their data type like this. Okay, right. So this was about loading the data, right? You can do explain your data set the way I did here. I did here explain. You can say explain. It shows you that what will happen when you launch dump divs, or what is going to go happen in the background. Okay, so it shows you that divs is basically a collection of fields. Okay, it's a storage, and then it will load the data from this location, and using what pig storage, right? Using pig storage. And once it has loaded, then it will do this operation. Okay. So basically, this basically when you say explain, it tells you that what is going to happen, what actually is divs. How did we reach to divs? If we have hundreds of steps before reaching to divs, it will show you all of those details. Okay. Now, yeah, we were talking about this one. Also, in case you are a heavy user, you become a heavy user of Pig Latin, you can start using Eclipse for syntax highlighting, or TextMate or Vim. These are the syntax available, which you can load into your editor of your choice and then start be comfortable. Okay. And also describe shows the schema, explain shows the detailed analysis of the query. We have stores. Store stores the data into a file or other storage. It can store into HBase, or it can store in the file system, or any other big storage available. Okay. Also, we can say while storing, instead of, if you don't say using big store comma, it will store the data in tab separated format. right? Also, when you say dump, it prints the data to the standard output. It's good and useful for the debugging purposes, and you can use it with the scripts that redirect output. Okay, so that's dump. Now the next step is that for each. Okay, for each basically iterates over the data. For each basically iterates over the data, right? So we can say we have what? What did we do here? So we have describe divs. So divs does not have a schema, and let's just say, let me just load something. So let me just load it. Okay, and we have got describe divs. Here we can say for each divs, okay, and then whatever we want to do is we can say generate only name, right? And say we call and divs. So we'll we are iterating over divs, and we are just picking up only one column. So basically for each goes over this whole set or this whole bag of tuples and generate another set. Okay, so that is the objective of the for each syntax. Now see, it is we just I said only pick generate the name, so it has only kept the name. If you wanted to say like this, so I'll just go into the details. So here, say we say we load this New York Stock Exchange daily as as this. Okay, so when we say describe prices, we have got this. If we say dump prices, we will get all the values in detail, right? Now we can iterate over the prices and generate something like close minus open. Close is some value here, open is some value over here. Okay, simple addition subtraction operations can be done on this. It's similar to saying select a minus b from my table. Okay, these are called projections generally. And in case you have not given them a name, okay, you generally said only this, say you only said this. In those cases you can use this kind of a format. $6 minus $3 means 1 2 3 4 5 6. Okay, it starts with 0 0 1 2 3 4 5 6 minus 3 0 1 2 3. So it's equivalent to the close minus open. All right, so now you can see that it's printing all the data. It might take a lot of time. In case all rows do not follow the same order of column, then it is going to be a problem. Then it is going to be a problem, definitely. All right. So we have got also, in case there are hundreds of columns, what you can do is you can say dot dot open, which means exchange symbol date open. All the columns up to open will be selected, right? Why? Okay, I need to first define prices, right? Now, if we say describe beginning, we'll say, see, exchange symbol, everything has come. If you are basically saying select star kind of thing, wildcard, open dot dot close, that is equal to saying all of these, all the columns between open and close. And then we can do a for each price generated, then the volume dot dot, which means all the columns are, including and after volume and adj close. Okay. Now a little difficult question to you. So here what's happening is we are saying go over each of these things and do subtraction. So question to you is, when we say for each prices and generate close minus open, how many reducers will be run? Okay. The answer is zero, because it is not involving, it is just like only having a mapper, right? But not having a reducer, which means the data, basically we are not going to run any reducer at all, because we are not summarizing the operation. We are just iterating over the data, right? So therefore there will be zero, there will be no reducer at all. Okay. Any questions on this? All right. Okay. Now, furthermore, on to for each. We talked about for each here, and again, I'm going to go into a little more detail. Now, here we loaded this data where the data was only of the plain type. Now we are loading a data called baseball. And how does this baseball data look like? I'll show you. Okay. So in this, you can see that there is this baseball data in which you have got the name of the person, right? Then name of the team, and then the various other information. Okay, he's a catcher, he's a designated hitter, and then you know so many games, so many. This is the history of the player. Okay, so if you see this data, this data, this is what? This is a bag, right? While this is a map, right? This is a map of values where key and values are there, right? While these are simple strings. If you have to load this kind of data and you are very sure that this data is well formatted, in those cases, you can simply load it like this. Okay. So we said going to load this data. So we are loading this baseball data into a variable called a set called baseball, and we are saying that it has got name as character array and bat as map, right? We are ignoring rest of it. Now dump b-ball. Let's see what happens. What? Oh, I need to go into data folder. Okay, it is still, I think it is still loading. How to skip a column while loading? Oh, that you can't do. So don't worry about that anyway. Because because when you say load, right, the actual loading does not happen right away, right? So when you are mapping the values to the actual one, you can in generate you can skip those columns. Okay. So basically I'm making a mistake over here, and let's see what happens. I think I need to correct name, then I need to put the team, and then I need to put the bag, and then map. And that is why the error will occur. That's why the error will occur. I'll try to somehow manage, but also here, if we have loaded our data and data is containing tuples like x and y, we can refer to them as t.x.t.dollar, right? To separate out the values from a tuple. Similarly, the bag projection as in like the way we do it in select star, what we can do is that load input as b dot bag and tuple is x and y, right? And tuple is x and y, and we can simply generate the x value of this bag, okay, this way. And similar is this one, right? So we can, if you just want these two columns, both the columns as such, if it has three more values and we wanted only two columns, then we could use it, this syntax, to pick up the value from the bag. Okay. So it has loaded something. Yeah. So basically it could not find a bag afterwards, so it has only loaded the first one. All right. So what was that sound? Any questions on for each? So here we should not be loading it like this. We should be loading it like we have got, what kind of data we have got? We have got, first we have a name, then we have got a team, okay, and then we have got a map, okay, and then we've got a map, not map, bag actually, okay. uh, Bag is what, what you get, traits, and traits is a bag, traits is a bag, okay. Right, so traits is a bag, and then this one. All right, so last one is your, if you say db Paul, What does it say? It says, just a second, what is this guy doing? So we have got char array, team, traits, and then we have got a map. This is correct, right? This is correct. So it says load baseball, and then we say error during parsing and counter identifier. Where is it? Let's see. Oh, thank you very much, Karthik. I've been wondering what mistake did I make. And I'm wondering like where this dum came in. DUM. Okay. All right. So this is how it is to be supposed to be loaded like that. See, it loaded everything. Now we can actually, uh, so vball is of this format. Is basically each each of the tuple is first name, team name, and then you have got traits, and then you have got games. Now we can basically do a sort of, uh, y- do a lot of magic on top of it. Say we want only the key part of it. Say we want to say we want to just print out these values, right? So in those cases you will have to, since there is only a single tuple, in those cases you will have to flatten this one, and you can refer these things back and forth. Okay. Okay. So yeah, yeah, this is clear, right? So all we did was we loaded this New York Stock Exchange data into divs, and then iterated over dividends, and we generated these values, and we can specify as also. As somebody was saying that how can we load unstructured data? You can load the uh, unstructured data as is. As you keep on processing, iterating over it group by, you can define their column names like the way we have done here. Dividend into 100 as dividend, and dividends, uh, and so on. Okay. So you can define it as you go ahead. All right. Also, the built-in function map is available here. What are the various functions available? You can use in the for each any of these functions. These are mathematical functions, these are string functions, these are datetime functions provided by this, and these are few functions specific to tuples and all. So basically you can convert something into a tuple. You can generate these tuples like this, and so on, right? So that so when you are iterating over for each, you can actually do a lot of churning, and most of these functions are available here. In case the function which you require is not available, say root mean square value. Root mean square value is not okay. Root mean square value is not available. Okay, and you want to compute root mean square value. So in those cases, you have something called a UDF. We'll go into UDF maybe in the second session, right? Now you have something called filter. Filter is similar to your SQL filter. So up to here, people should not be having any questions, right? Now filter is like your standard SQL filter where A is less than this, B is less than that, right? So we have loaded this dividends. Now the next step is that we can filter our data with something like this, saying, right, and we say dump. So it will just match all the symbols starting from whose name starts with CM. And note the dot over here. Okay. So it's basically a regular expression which says CM followed by dot. Dot means anything, a single character, any single character, followed by star means zero or more of any single character, right? So that is how the regular expression works. And you can also have a negation kind of a condition in filter, like filter divs by not of this, where symbol does not match this regular expression, right? So this is what this is what it means. So while filtering the data, you can either do where this matches that, or you can say negation of that one. Also you have logical operators where logical operators like and this condition and this condition, and we have and operation between. Okay, you can see more operators available over here. So there are arithmetic operators, there are Boolean operators, and there are relational operators. Okay, you can join, and we'll talk about all of these we are going to talk about it, but you can see all these arithmetic operators. Okay, so basically this is quite handy, and this is equal to the where clause of the SQL. Now, right, so how many reducers are there in filter divs by symbol matching CM star? Quickly, anybody? Because as we talked earlier, all of these big commands get converted. All get converted into MapReduce under the hood. 0. Prasanna says 1. Anybody else? But why do we need a reducer? Tell me. We are not running any group by, right? Therefore, there is no need of reducer. A mapper will simply do this, go one by one record and keep on applying this filter, right? So similar to your SQL, you have order by and distinct, right? Order by means order this by a particular value, by this, okay? And distinct means you go over the data and then prepare distinct. It's pretty straightforward, right? For each is okay, and then you can say distinct, and you get the distinct value, right? Like, and you can keep on chaining these operators end to end, right? Here, let me just say, so if I say the next step is that I say unique symbols and unable to find dump unique symbols. Did I make a mistake? Oh, right. Again, typo. So this is clear to everybody, right? The order by and distinct. This is standard. It's like similar to SQL. It should not have any problem at all. But feel free to ask any question right now. So distinct is exactly like the distinct you have in your question with this one. So when you are having reducers, right? When you are having distinct would require you to have reducers because that would require sorting and the and then you need require your reducers to do the sorting for you, do the distinct for you. Okay. So this is the distinct values, and if you want to see, so this is what it is. So it shows you the complete plan of what is going on. First, it computed divs by loading this file using pig storage. Then, then what it did was it did a for each on this. Basically, this part for each. Okay, the symbols were computed over here, and once symbols were computed on for each of the bag, then it did a rearrange, and when you see rearrange, then that means there is a reducer there. Okay, so this is the reduce plan. Do you see at that stage? 79, 80, 81, and I'm just trying to figure out what those numbers mean. Okay. Okay, so this is clear to all of you, right? And how many reducers? This is also clear to you, or do you have any questions related to this? Is everybody clear why there has to be a reducer in this? Okay. Now the next step in case of a pig is a join. Join is like your standard one, saying first we loaded the data, then we did a join. We loaded New York Stock Exchange daily and New York Stock Exchange dividend. And then in both the cases we have symbol here as well as here. We join the data on the symbol. All right. Now remember that join when you're joining, it always happens over a column. Okay. It doesn't happen the way it used to happen in case of SQL, where you know, join this table and this table on a less than equals to b plus 5. That is not something which is supported. And why is that? Can anybody answer? Why is that? Why it is always on a either a composite key or a single key like this? Why not we have a syntax like joined join daily? If you remember our on daily dot date is less than divs dot date, like this kind of syntax is not supported. Can anybody tell me why it is not supported? It's always either a single key like this. We are joined these two data sets, join daily by symbol and divs by symbol. And similarly here, daily by symbol comma date or daily symbol comma date, we can do that join also. Or the one which makes more sense is the exchange. The one which makes more sense over here is the exchange, right? So why the kind of a this kind of a join is not supported? Something should be a common field to join. Okay, okay. But that is also true for SQL, standard SQL, right? So the reason is that under the hood, this join is going to use map reduce, right? Where on whatever column you are joining, that will become the key for both the mappers. Mappers on both the table will generate the data with that particular key. And therefore it makes a lot of sense to join only on the column. Basically, it has to use MapReduce to join these two data, right? And therefore, it cannot, I mean, it will not be possible for it to join the data on, say, on the conditions instead of uh, instead of a rigid column. Okay, so let's see what happens when we join it. And we say describe. First, we say describe J and D. It shows you a new it shows you a new set of columns, right? Whose names are like daily colon colon exchange, daily colon colon symbol, okay, and that way, right? And here we have joined it based on that. So basically all the columns are gathered together, and the column name is prefixed with the set name, okay? And also note that the self join is not possible. Therefore, you will have to load the same file twice with the different names and then join it, just like this one, right? Got it? Got the picture? And joining is not possible the way it used to happen earlier by on conditions. For that, you'll have to do the filter. After joining, you have to do the filtering. Okay? Is it clear to you guys? Because there is going to be assignment on on all of these. So if there is a doubt, let me know. Okay, it'll be great if you ask questions. If you don't have any questions, I'm I'm really a great teacher or I'm really a pathetic teacher, because if I'm a great teacher, you understood everything. And the other reason could be I'm really, really pathetic teacher, which you don't like. Great. So here what I'm trying to do is I'm trying to join it. Do a self join. Ideally, in the cases like say we cannot do something like this. Okay. Let's say this. So instead of this, I cannot just say join divs with divs1 by symbol. We can't do that. Okay. We can't do that. Okay. Is that clear? So other portion of the game is that limit and sample. Sample is something very, very interesting. Sample is really interesting aspect. So limit is just take first 10 records and then do something about it. Instead of loading the whole data, we can do just load 10 records and then do the whole logic, right? And ideally, whenever you are processing the data, you should just, in the first line, just after load, you should put limit. Okay. And once you are done, once you are, the way we were, everything of our whatever we were doing, like here, okay, whatever we were doing over here, if we had put a y- you know let me just show you what I'm trying to say. Okay. So we have got daily, we are loading it, right? Now, what we could say is daily, and daily 10 we say limit daily to 10. Okay. And similarly here, okay, and we say divs 10 is our divs 10 is our limit divs 10. Now, if we say dump daily 10, what's going on? Yeah, I made a mistake. Hmm. So ideally what you do is when you're loading a file, you name it full, and then you say daily is limit daily full by 10. Similarly here, divs full, and then you say divs equals limit divs full to 10, right? And then you join. Now, the thing to be noted is that the results you are getting, you'll get the results really, really fast comparatively. Okay. I mean, it won't take too much of time. But and at the end of day, when you're doing when you're cleaning up your script, you just remove this line, and then you change it to something, right? Change it to daily, and the rest of things will remain same. Okay. So input part does not exist. Okay, no worries. So we'll just do no worries. I'll just do data, cd data, and okay, dump JND. So actual work starts when you say dump or store. Till that point of time, nothing happens. So that's the role of your limit function, right? So and then there is something called sample. We'll continue from sample tomorrow or the next Sunday. Do not worry about it. Okay. And till then, you should go through the exercise at the end of the session. Okay. So whatever we have learned today, most of the exercise you can do, except for the last question, you can do all the exercises based on that one. All right. Let it go. So from sample onwards, we'll talk about it tomorrow, right? And till then, you go through the exercises at the end, I mean, available on the website. Okay. And let's meet on next Saturday. And so, see, next Saturday is 2nd October, and most of you are, it's a long weekend, so most of you might not be available. So, okay, so should we keep a holiday on the next weekend? Okay, Ishwar is not here. Other people have asked me to keep a holiday. Okay. Yes, for me, I mean, Pranav, you will be here or you will be on a trip somewhere? You will be available? Oh. And for Prasanna and Jagan, you are anyway outside. So for you, it won't be a holiday, right? Right. Okay. Okay. So, I mean, because other people are also asking for that weekend off. So next weekend, although I'll be here, although I'll be here, next weekend, let's keep it off. And then, all right. So let's meet after next to next weekend. Okay. Till then, go through the exercises. All of these exercises are, solvable. As you have seen the general syntax of join, filter, group by, and all of this. So it should not be a problem to you. Okay. Only the special cases are remaining. like co-group and inner join, outer join. Only those parts are remaining. Okay, so it shouldn't be a problem. So go through these 3-4 problems on pig, and you should be able to handle it. And whatever exercises we have gone through today, go through those again. Try to load the data, try to do some parsing. Whatever you would do in SQL, you try to do the same thing. All right. Okay then. Good night, guys, and I'll upload the video by tomorrow, and the presentation will be available very soon. So have a good weekend and have a good time. Bye Prasanna, bye Jagannath, and bye Pranav, bye Karthik, bye Ishwar. Good night.